Assalamu alaikum guys, hope you are all doing fine. In this video we are going to solve a problem through some logic combinations of the circuits. I've placed some components which we can search in the library of the component mode, and these components are named as this is a keypad which gives input through its x and y axis, and through this IC MM74C922. This is used to control the keypad and give the inputs furtherly. As you can see here, we can give input here, as you can see, which is displayed by a BCD7 segment and green in color. Furtherly, if we see that we are using a 4008 IC, which is a 4-bit binary full adder, and furtherly it is connected to an output. And let's close the simulation first. And two 4008 ICs used for binary full addition. And let's begin our simulation. First we shall see the problem. This was our problem, that design a 4-bit combinational circuit by means of a 4-bit binary adder. The overall problem is distributed into a 2-stage problem. 4-bit binary adder should be utilized as a block component. Let's skip this. We should come to the first part, that is A part. In the first stage, design a combinational circuit in order to implement following functions. When the input provided is an even number, 1 is added in order to convert it into an odd number. No processing is required for odd number input. The output will be the same as its input. I will explain this to you later. In the second stage, reconstruct the original values that contain odd well as even values. The output provided by the first stage will serve as the input to this stage. Now we shall simulate this in Proteus, and we will not make PCB in this tutorial in this video. So let's begin our simulation. As we can see here, the inputs given to this input, basically this shows our first input. So these are the inputs which are given to this LED, and furtherly they are attached to this 4008 IC, and and in case of B inputs, the 3 B inputs that are B2, B3 and B4 are attached to an enable circuit, enable input you can say, and B1 is attached with a NOT gate and inverter 7404 with the C, or you can say A, which is also given to A3. So, and here our output or the fast carry is grounded. Further, its output is given to this LED and to the as the input, as the A's input, that are A1, A2, A3 and A4 of the second binary adder. There are 2 enables in this. The first enable is attached to B2, B3, B4, and second one is attached with this. This is grounded. And now let's see, this is the final output. These two will be our outputs, this one, and this will be our input. So let's begin our simulation. As we can see here, the input given to us is 0, that is 0. And when as we can see there, here as the problem states, that when the input is provided as an even number, as we can see here, 0 is an even number, so 1 is added in order to convert it into an odd number. As you can see here, through this inverter, as we are giving 0, the inverter inverts the 0 value into 1, and here the output value is given 1. And if we see in the second part, it says that no processing is required for odd number input. The output will be the same as its input. So here we can see, as the problem stated, that when the number given by the input this is the input of this adder. So as you can see here, 1 is an odd number, and it is given the input at the IC 4008, and output is given here 1, and it is not changed. So hence our first problem is solved. Now let's proceed to the B part, which stated that now we shall convert both of our values that are even and odd, both values. As we can see here, if we give 7 here, 7 here, keypad gives us 0. It is not a real keypad. It only works with microcontroller circuits to give its proper simulation and inputs and outputs. So we can see here, 7 gives us 0. So when our input here is 0, it is converted into output as 1, and furtherly this output is converted as into 0, as this was stated in our logic, that in the second stage reconstruct the original values that contain odd as well as even values. The output provided by the first stage will serve as input to this stage. We can see here 0 was first converted to 1. 0 was an even number. It was converted into 1 by this inverter, and this was converted through when these two enables were 1. If we off these two enables, we will get the solution of our first part, that was the input of this stage should be same as the output stage, but when we on our enables, it will give us inverted values. So this value will be added and it will be changed. So that was this problem, and hope you got the information you were seeking, and that's all by my side.